So I can't remember last time someone brought up the idea of a domain. Was it in this class? About the numbers you're allowed to plug in? Yeah, we got it confused with parameters, but it's a really important idea. So domain is what you are allowed to plug into your function. When you create a function, you can say what the domain is. So I can make up this awesome function. Somebody give me an NFT for creating this function. I'm going to say f of x equals 2x plus 3, but this is only valid for x greater than or equal to 0. So I've restricted the domain here. This is a domain restriction. F of 1 I can do because 1 is greater than or equal to 0. And we said last time, and I agree, we just plug in the 1 for x. So that would give me f of 1 is equal to 5. Because I just plug it in, right? I can evaluate these things. What if I evaluate f of 0? Can I do that? Sure. Because it says greater than or equal to 0. So f of 0. Okay. What can I do that would break this, though? F of -1 will not work. Even though you think I can plug in -1 for x, you first have to check if it's okay with the domain. Domain is like dominion, right? You see dominant in there. You see something that controls something else. F of -1 is undefined. Why? Because the domain said so. So -1 does not meet the condition x greater than or equal to 0. We use this when we build new functions from pieces of old functions to build piecewise functions. We may have different rules for different pieces of the domain. So I'm going to use p for p of x here. P is piecewise. And I could say this is equal to 2x plus 1 if x is greater than or equal to 1. And it's equal to x squared if x is less than 1. And this is fine as long as I understand that I have to look at this rule first. So we can evaluate some of these things. We can evaluate p of 0. We have two possible rules. We need to know, am I greater than or equal to 1 or am I less than 1? So which of these two do I need to use? Yeah, this is 0 is less than 1. So we will use the x squared rule. So 0 squared is 0. So p of 0 is equal to 0. What about p of 2? Yes, I'll have to use, so 2 is greater than 1. So I would be using the 2x plus 1 rule. Finally, how about p of 1? 1 is less than 1 or 1 is greater than or equal to 1? Statement 1 greater than or equal to 1 is not incorrect. So p of 1 is equal to 2 times 1 plus 1. So p of 1 is equal to 3. Now, what I want us to be able to do is to use this to make letters and write words. Let's say I wanted to write a W. So is this the graph of a function? Yes, it passes the vertical line test, right? That's all that matters. As long as it passes the vertical line test, we're good. How many different pieces do you see here? You see 4 different pieces, and each piece is a line, right? So I'm going to make a piecewise function that has 4 different linear pieces. Now, can I figure out, hey, there's a point right here at 4 or at 0, 4 that could be helpful to me. And there's a point right here at 2, 0 that could be helpful to me. Do you agree? So now what I need is to find the equation of the line that passes through 0, 4, and 2, 0. But we did that. So can we find the equation of this piece of the line? Yeah, we know how to do that. So we need to find the equation of the line that passes through 0, 4, and 2, 0. I don't know what it is, but okay. So you claim it as y equals -2x plus 4. Awesome. I can use that, right? Because this would have been what I would have drawn my hand. However, I don't want that whole thing. What do I want to do? I want to restrict it. I don't want the whole line. I want to restrict between, what do you think? X between 0 and 2. Now we just have 3 more lines to do like that, and we got a letter.